We're going to go ahead and get started. It is my privilege this evening to introduce Dr. Mayer as our speaker. He is a distinguished professor of psychological and brain sciences at the University of California, Santa Barbara. He has a PhD in psychology from University of Michigan and a BA in psychology from Miami University. With more than 600 publications and over 40 books, he's the most cited educational psychologist according to Google Scholar and is in the top 0.01% of scientists in the world. His contributions are foundational to the fields of psychology and education. For this talk, please remember to use the question and answer for questions, and please join me in welcoming Dr. Mayer.
Thank you very much, Chris, for that really lovely introduction. It's really a pleasure to join you here at Johns Hopkins School of Education. I just want to spend a second to introduce the talk, and then we can go to the slides. Overall, my work over the years is focused on a deceptively simple question, which is, how can we teach in ways that help people be able to apply what they've learned to new situations? So this is really the classic issue of transfer, which has been a fundamental theme in both psychology and education for more than 100 years. One approach to teaching for transfer that I've kind of stumbled upon is to provide instructional messages that use both words and pictures, which I call multimedia learning. The pictures can be static, such as photos or illustrations, or they can be dynamic, such as video, animation, or even 3D immersive virtual reality. The words can be printed or spoken. And the rationale for exploring multimedia learning is the idea that people can learn more deeply when we add pictures to words. That's kind of the idea I want to explore with you today. In other words, when lessons are in multimedia form, people learn better than when they're solely in words. As some of you may know, for the past decades, my colleagues and I at UCSB have been trying to understand how multimedia learning works. So this is an example of the science of learning, and how to design effective multimedia instruction. So that's kind of an example of the science of instruction. In this talk today, I want to share with you the fruits of our investigations, which have involved more than 200 experiments and the development of more than a dozen evidence-based principles of multimedia instruction. So I will share my screen so we can start this journey together. And I'm really looking forward to your questions. I hope we'll have a nice, vigorous question and answer period. The theme of today's talk is really an attempt to apply what I would call apply the science of learning to education. This is just one example of how we might do that. I'm looking for evidence-based principles for designing effective multimedia instruction. And I would just like to acknowledge the supporters of this research, both the people who have provided funds and, of course, my students and colleagues and collaborators. The general domain that I'm working in, as I mentioned, is applying the science of learning to education. And that involves, I think, the science of learning, the science of instruction, and the science of assessment. So I want to take just a second to look at each of those to just give us some context. And I want to spend most of this talk on looking at principles for effective multimedia instructional design. So my motivating question is, how can we help people learn so that they can apply what they have learned to new situations? One way to do this is to focus on instructional methods, which is kind of on the left side of the slide. And that has kind of got me into this area of multimedia learning, which is the idea that maybe adding graphics to words could help people learn better. And also computer games. Can we design games that will help people learn? Another way to promote transfer is to try and help students develop learning strategies that will make them more effective learners. So this kind of branch on the right is kind of goes to that area. Today, I want to talk about this leftmost branch, multimedia learning. I also want to mention that some of my thinking is informed by my experience as a local school board member for the past 40 plus years. And if you don't believe me, I'm showing you my 40-year pin here. Part of my experience led me to write this book called How Not to Be a Terrible School Board Member. It's based on little mini episodes where school board members have done some pretty ridiculous things. But I do appreciate kind of having some experience looking at things from the viewpoint of what happens in a school district. When we look at designing instruction, which is kind of the theme of my talk today, instruction is often based on what I would say good intentions. Sometimes we look for expert opinion on how to do things. Sometimes it's guided by fads, kind of what's the most popular way to do things right now. Sometimes ideology, all these different isms of how we should do things, or testimonials or common practice. What I have tried to do in this talk is look at what would happen if we try to base it on the science of instruction, the science of learning, and the science of assessment. That's the approach I'm trying to take. Okay. So we seek to design instruction that is evidence-based, so it has some research behind it, grounded in a theory of how people learn and how to help people learn, and focused on learning outcomes. So today, I just kind of tried to organize things by first starting with some examples, then looking briefly at the science of learning, assessment, and instruction, and then looking at basic principles of multimedia instruction. So here, some people are into instructional objectives, so I tried to think of what are my actual objectives for today. So here they are, I guess. This is one way to define them. Let's just look at some examples of multimedia messages, because what I mean by multimedia is instructional messages or instructional communications that involve words and graphics. So in this case, I'm just looking at kind of PowerPoint slides that come from kind of medical websites or medical instruction, because I don't know, I just decided to focus on those. If you look at a slide like this, of course, we don't have the content knowledge to know what it's talking about, but if we were going to criticize it, one thing you might think about is, you know, this graphic is very pretty, and it kind of relates to the title of Surfing Through the Bloodstream, because this guy is surfing, but it's basically irrelevant to the instructional purpose. So this slide violates one of my principles, which is the Coherence Principle, that we should root out any extraneous material. Let's look at another slide. This one is from a children's medical site, where it kind of just shows some of the parts of the digestive system and looks at and briefly describes them. If we ask what's wrong with this slide, one thing we might focus in on is the fact that we have kind of a legend here. If we want to know about the esophagus, we have to see here 2 esophagus and then look for 2 in the body to see how they match up. Or if we want to look for the small intestine, we see that 6, and then we have to look for 6 in the body. When we have to look back and forth between the legend and the graphic, that causes a lot of extraneous processing, wasted processing. And because people have a limited working memory, if they're using it to kind of look back and forth and try and figure out where they are in the legend, that's processing they can't be using to actually understand the point of the presentation. This violates what I call the spatial contiguity principle, which is printed words should be next to the part of the graphic they're talking about. Whenever there's a legend or a caption, that's violating this principle. Let me give you just one other example here. Those of you who are more into the science side of things might recognize what this is about. It's an attempt to explain how photosynthesis works. What's wrong with this slide is, well, there's just lots of things wrong with it. One thing is, it's overwhelming. We don't know where to look. It violates what I call the signaling principle, which is the idea that we need to guide people's processing. We need to show them where they should be looking. It also has a lot of jargon and acronyms like ADP, ATP. People might need what I call the pre-training principle. They might need to know what these terms mean before they can understand what this whole flowchart is about. So those are some examples of multimedia messages that, we're all kind of used to PowerPoint slides. So it's kind of always embarrassing for me to give a talk and look at my own slides. But when we look at them, I think our consensus is that maybe we could do a better job of trying to explain things with words and graphics. So let me just take a brief look at learning, instruction, and assessment so I can kind of just touch on these ideas. All I mean by learning, I think the most important thing to think about learning is that it involves a change. We're trying to, when people learn, there's a change in what they know, and that's caused by their experience. In multimedia learning, the experience involves words and pictures. So maybe they get a narrated animation, or they are watching an instructional video or something like that. Three really important concepts from cognitive science are the idea of dual channels, limited capacity, and active processing. So people have separate information processing channels for verbal material and visual material. They're processed in different parts of the brain. They're represented differently. Limited capacity is the idea that we can only pay attention to a small amount of material in each channel at any one time. So even though we can present a lot on the screen, people can't really attend to it and process it, just a little bit of it. And active processing, this is the idea that deep learning occurs when learners engage in appropriate cognitive processing. And this includes being able to attend to the relevant information, mentally organize it into some kind of coherent structure, and integrate it with their relevant prior knowledge. So the challenge for us as learners is we have a limited capacity in working memory, but with that capacity, we have to engage in these processes of selecting, organizing, and integrating. So I represent that in this little flow chart. Cognitive scientists like flow charts. So here's mine. The multimedia message is presented. It comes in through our ears and eyes. So if the words are printed, they come in through our eyes. If the words are spoken, they come in through our ears. The pictures come in through our eyes. If we pay attention to some of this incoming information, it gets into working memory, because when it's coming in through our senses, it fades very rapidly. So we want to get it into our working memory. In working memory, we can mentally organize it into a verbal model and a pictorial model, and then integrate that with relevant prior knowledge that we activate from our long-term memory and bring into working memory. So we want to connect the visual and verbal information and also connect it with prior knowledge. I hope that makes sense. So those are the ideas that the major processes in meaningful learning are selecting the relevant information, organizing it, and integrating it. So effective instruction needs to guide learners through these processes of what should I pay attention to, how should I organize it, and how should I connect it with other pieces of knowledge I have. So that's an introduction to learning. I don't want to spend too much time on this. For assessment, we kind of always start with a learning objective, which is a description of the intended change we want in the learner's knowledge. And two classic ways to assess learning outcomes are retention tests and transfer tests. I want to focus most on transfer tests because I think that is really the goal of most education. So this involves being able to take what you've learned and use it in new situations. Of course, we need to remember what we've learned. So retention tests are relevant and have a place, but on all the research I'm going to talk about, all the dependent measures are transfer tests, kind of looking at people's ability to solve new problems. Meaningful learning and rote learning, this distinction has a long history in our field. And what I mean by, and of course, no learning, we know what that looks like. You don't do well on retention or transfer. Rote learning is kind of indicated by good retention, but poor transfer. And meaningful learning involves both retention and transfer. So transfer is kind of a good way of telling whether people have engaged in meaningful learning. And the metric I'm going to use in most of the studies I talk about is effect size, which I think is, and when we're talking about intervention studies, is probably a more useful metric than significance, which is what psychologists like to talk a lot about, significant at the 0.05 level. I mean, that's good. That's, of course, something we want, but effect size tells us how many standard deviations better the experimental group performed compared to the control group. So it gives us a common metric for comparing across studies, and it allows us to see how powerful our intervention is. For me, any effect size greater than 0.4, I think, is educationally important. And so I'm looking for instructional methods that cause an effect size of 0.4 or greater. I won't go through computing effect size. And then science of instruction. Instruction really involves trying to help the learner have experiences that cause learning. So what we're really looking for is how to help people learn. Multimedia instruction is instruction that uses words and pictures. And the kind of main concepts I want to focus on here are three demands on our working memory through instruction. One demand is extraneous processing. So when we have poorly defined instruction, it creates extraneous processing, which is cognitive processing that is not, doesn't support the instructional objective. Essential processing is cognitive processing to mentally represent the presented material. So it's basically to just get what's being presented into our working memory. And generative processing involves trying to make sense out of that material. The amount of essential processing depends on how complex the material is. The more complex it is, the more we have to engage in essential processing. For generative processing, this is probably caused by the learner's motivation to try and understand the material. So this means in terms of instructional goals, I have three basic goals. One is to reduce extraneous processing to kind of so that working memory can be freed up to engage in these more productive kinds of processing. To manage essential processing, because if something's very complex, it might overload working memory. So we have to manage that. And also to foster generative processing, because students typically do not engage in deeper processing unless they're kind of primed to do it. So that's kind of my long-winded introduction to the kind of the big ideas that kind of underlie our research. And now I just want to look at instructional methods that are aimed at each of these goals: reducing extraneous processing, managing essential processing, and fostering generative processing. Does that make sense? I see all the heads shaking, sure. So let's start to look at some of the principles. I really want to share 12 principles of multimedia instructional design, starting here with the first one, the Multimedia Principle. So what's my rationale for being interested in kind of what I'm calling the multimedia principle? Well, it's this intriguing idea or hypothesis that people learn better from words and pictures than from words alone. In education, traditionally we focus on words for our communication with learners, either spoken words in a classroom, let's say, or like what I'm doing right now, or printed words, maybe in a textbook or on the screen. And what I really want to look at is what is the value added of adding graphics, pictures, to help people understand better. I kind of got started in this with this passage. So this is the one that kind of got me started. This is from a passage in the World Book Encyclopedia way back in the 80s when it was actually a print document. It's explaining how bicycle tire pumps work. And most of the article really doesn't explain how it works. There's just like 2 little sentences here at the bottom that I put in italics that explains how a tire pump works. As the rod is pulled out, well, I won't read this whole thing. Air passes through the piston and fills the area between the piston and the inlet valve. As the rod is pushed in, the inlet valve closes and the piston moves down, forcing air through the outlet valve. When I ask students to read this and then take a retention test and a transfer test, they remember some of the material on a retention test, but they do not do well on a transfer test. That led me to think about, well, how could we help them? So I created this little multimedia lesson, which has a picture of or really a diagram of the pump when the handle is up and when it's down. It has the same words as in the lesson. As the rod is pulled out, air passes through the piston. But it kind of shows where in the graphic these words refer to. So it's trying to help you connect the words to a visual representation. One thing so when we do that, people learn better. I'll show you some results in a minute. Another way to do this is to just have a narration where people listen to the description of how a pump works, or have a narrated animation. So those same words, but along with an animation. So this is showing you slides from an animation. It lasts about 30 seconds. So this is a very short lesson that just explains how bicycle tire pump works. The kind of retention questions we might ask is, please write down all you can remember. And transfer tests, we can ask people a redesign question like, how could you make a pump more reliable or more effective? Or we could ask a troubleshooting question like, suppose you push up and pull down, but no air comes out. What could have gone wrong? Or we can ask a more conceptual question like, why does air enter the pump or exit? And you're supposed to invent the idea of difference in air pressure, which is never mentioned in the lesson. I want to show you kind of what really got me started here, because we have a technique that can increase people's performance on a transfer test by at least 50%. If you look at the white bars, this is words only. So only narration or only text from multimedia presentations, ranging from that passage that we just looked at about pumps to all kinds of other topics as well. The y-axis is showing you percent correct on a transfer test. The dark bars are words and pictures, so narration with animation or text with illustrations. You can see that adding graphics to words greatly improves people's performance on a transfer test, sometimes doubles it. So somewhere between 50 and 100% better performance. This kind of encouraged me to think maybe there is some value in trying to use graphics and words together to help people understand concepts. So that's what I mean by the multimedia principle. The problem is all graphics are not equally effective, and it's quite possible to have graphics that are useless, like Some of those I showed you in the examples at the beginning. So that kind of got me started down this journey of, well, what are the principles of multimedia design? How can we design effective multimedia instruction that really promotes transfer? So first, let me look at some techniques for reducing extraneous processing. So these are all techniques trying to make sure people don't waste their working memory processing things that have nothing to do with the instructional goal. So the 5 principles I want to look at are coherence, signaling, redundancy, spatial contiguity, and temporal contiguity. So let's start with the coherence principle, which is basically the idea that we're all taught anyway when we're instructors to keep things simple, focused, weed out irrelevant material. This slide comes from a lesson on how a virus causes a cold, kind of ironically relevant today. And this is one of the steps where the virus breaks out from the host cell and starts invading other cells. In the control version of this, the words just describe what's going on. In the kind of enhanced version, we add interesting but actually irrelevant material, which people have called seductive details. So in this case, the seductive details are in the last 2 sentences, which talk about the idea that, a study that was done in Pennsylvania showed that people who make love once or twice a week are more immune to colds than people who abstain. We did a kind of pilot study and found that we had USCSB students rate how interesting various facts about viruses were. And this was their #1 most interesting fact. So we put that in here. So each of the slides either has a seductive detail or not. The purpose of adding this material traditionally has been to try and increase motivation and interest. But what happens is when you add material like that, it actually depresses performance on a transfer test, and people are less able to use what they've learned about infection to solve new problems. So the coherence principle says people learn more deeply when extraneous material is excluded rather than included. Out of 19 experiments that we did, we found support for that in 18 of them, and the median effect size is 0.86. So this means that the people who had the extraneous material removed performed 0.86 standard deviations better on a transfer test than people who had that interesting but irrelevant material or other kinds of extraneous material in the text. So this principle is pretty straightforward. It just means weed out anything that's not all that relevant. That's kind of why my slides are so bare bones, sorry. And this kind of shows you all the studies. On the left is the citation, and the content tells you what the lesson was about, lightning or viruses or ocean waves. And then on the right is the effect size. So it varies from study to study. So we can either take away seductive details or just remove, extra facts that were in there. Both of those are helpful. Even removing background music from a lesson is helpful. The next big principle I want to talk about is signaling. This is also, if we can't take away the extraneous material, let's direct the learner to look at the key material. So signals or cues kind of show the learner where to look. We can do this in 2 ways. We can kind of have verbal signaling where we kind of emphasize the important parts of the verbal message, or we can have visual signals where we emphasize the important parts of the visual message. So when it's visual, we might have arrows or pointing to things or putting things in red color. When it's verbal, we might put things in bold font, or if it's spoken, we might emphasize it with our speech. This comes from a lesson on how airplanes achieve lift. And in order to emphasize it, we can add headings, like these three headings I have here. Or if it's being spoken, we can use emphasize it in our speech to kind of say, wing shape, curved upper surface is longer. The surface on top of the wing is longer than on the bottom. So that's just a way of emphasizing the words we want people to focus on. When we're having visual signaling, we can do that. Let's say, here's a lesson on neural transmission. It's in Chinese, so it might be hard to follow the graphic part of it. But we can either have our little agent not point as she's lecturing, or point to what she's talking about as she lectures. So she's either not signaling or signaling. What we find is that people learn better, more deeply, when we add cues that highlight or signal the main ideas and organization of the material, either verbally or visually. In 26 out of 28 experiments, we get that pattern, and the median effect size is 0.7, which again is a good size effect. So now we have two ways of reducing extraneous processing, both the coherence principle and the signaling principle. Let's see what else. Oh, and this shows you just some of the studies. So for verbal signaling, these are the studies, and then different contents, a lot of scientific type content, some social science type content, and then a variety of effect sizes. And for the visual signaling, most of them deal with neural transmission, but a few deal with other things. The next kind of way to think about dealing with extraneous processing and reducing it is to look at this situation. Let's say we have a narrated animation on how lightning storms develop. So on the left is a slide from a 2.5 minute narrated animation that describes lightning formation. So the voice says things like, as the air in this updraft cools, water vapor condenses into water droplets and forms a cloud. And then you see an animation of the cloud going up. You might think it would be helpful to add also on-screen text. So on the right, we have the animation, narration, and what I'm calling redundant on-screen text. So at the bottom of the screen, it has printed text that says the same thing as the spoken text. Although some people think that might be better, what really happens is that turns out to depress performance on a transfer test. And the idea is that when we add the caption at the bottom, it creates what a situation people call split attention, where if your visual attention is focused on the printed words, you can't be looking at the animation, so you might miss something. If you're looking at the animation, you might not have time to read all the printed words before the next text comes. I won't go through all the slides of this. So for the test, let's say for the lightning lesson, we could ask people to write down what they can remember. And on a transfer test, we could ask questions like this. How could you reduce the intensity of lightning? Suppose you see clouds in the sky, but no lightning. Why not? That's kind of a troubleshooting question. And what does air temperature have to do with lightning? Or what causes lightning? Those are more conceptual questions. So if we look at just transfer test performance, we find that people do learn a little bit better from animation and narration than from animation, narration, and on-screen text. It's almost negligible, but this is certainly telling us there's no real benefit to adding on-screen text. I would just add a little, what I'm calling a boundary condition. The on-screen text is helpful in certain situations. For example, if you're learning in a second language, it can be helpful. If some of the words are highly unfamiliar, even hard to kind of hear because the sounds, I mean, they're just unfamiliar sounds altogether, then it's good to have printed text. And here's some of the studies that look at the redundancy principle. Next, let's look at another way of trying to reduce extraneous processing, which I call the spatial contiguity principle, that it's better to have printed words next to the part of the graphic they're talking about rather than as a caption. It's very typical in textbooks to see a graphic with a caption at the bottom. This is the way we're almost forced to do it. That's what is expected. It's just a terrible way to do it, unfortunately, based on our research. And in fact, the way PowerPoint is set up, it kind of encourages you to do this. So this is an example of what I would call a separated presentation for an explanation for how a car's braking system works. The top frame shows you what the system looks like before you step on the brake pedal. The bottom frame shows you what the braking system looks like after you step on the brake pedal, and the text at the bottom explains it all. This requires you to look back and forth between the words at the bottom and the graphic. So when it says car's brake pedal, we all know where to look because we know what the brake pedal is. But when it says a piston moves forward, we might not know where to look. A lot of people don't know what a piston is. So they might be looking all around for where's the piston. That is wasted processing. That creates extraneous processing when you have to look back and forth between the printed word and try to find in the graphic what it's referring to. In an integrated presentation, we make that task a lot easier by putting the words next to the part of the graphic they're talking about. So this has exactly the same graphics and words, but we are showing people, we're kind of both signaling and using spatial contiguity, showing people where to look. So a piston moves forward, it shows where the piston is. Fluid moves, it shows where the fluid is. Wheel cylinders, it shows you where the wheel cylinders are. So the idea is this kind of presentation reduces extraneous processing. If we look at a lesson like the brake lesson, the transfer questions are things like redesign questions like how could you make brakes more reliable or effective? Troubleshooting questions like suppose you step on the brake pedal and your car doesn't stop, what could have gone wrong? Or what happens when you pump the brakes? Questions like that. We can have the same thing with animation. With an animation, we can, so this is the lightning lesson again, we can have the words printed at the bottom as a caption, or we can put them next to the part of the graphic they're talking about. What we find is in 9 out of 9 experiments that we ran, people learn better when corresponding words are placed next to the graphic that they're part of the graphic that they're referring to, rather than far away from them. So, and this generates a median effect size of 0.82, which is considered a large effect. What I like about spatial contiguity is we're presenting exactly the same information with an integrated or separated presentation, but the integrated presentation is much, much more effective. So just putting the printed words next to the relevant part of the graphic greatly improves people's ability to learn, because I think it's reducing extraneous processing. And this just shows you some of the studies that we're getting that from. Lastly, in terms of reducing extraneous processing, we can look at a lesson where we have, let's say, a narrated animation. So maybe think of the lightning passage where there's a voice that's telling you what's going on and there's animation that's going on. We can have a situation where that's simultaneous, which is our original lesson. So a narrated slide where what the voice is saying is portrayed on the screen. Or we can have successive presentation where first you hear it in words. So you listen for 2.5 minutes and then you watch it for 2.5 minutes, or vice versa. First you watch and then you listen. You might think successive might be better because you are getting twice as much exposure, but the research shows that simultaneous is by far better. And I think the reason is when you kind of get the words first, you have to wait a long time to connect them up to the images. You've lost a lot of the words by the time you get to see the animation, or vice versa. So in 8 out of 8 experiments, people learn more deeply when corresponding graphics and narration are presented simultaneously rather than successively, with a huge effect size greater than 1. So when we can improve performance by a whole standard deviation, that's really eye-opening. So, and these are some of the studies that looked at that, some of our early studies actually. So just to summarize, how can we reduce extraneous processing, this kind of wasted processing that just uses up our cognitive capacity? We can eliminate extraneous material in the lesson, or we can somehow highlight or cue that essential material. We can not add on-screen text to a narrated presentation. We can place printed words next to the corresponding graphics, or we can present corresponding narration and graphics at the same time. These are all good techniques for reducing extraneous processing. This was kind of the first phase in our lab's research on multimedia learning. Just the first idea we had was, let's reduce extraneous processing. But that's not quite enough. Even if you have freed up people's working memory, they still might not be able to fully benefit from a presentation, especially if it's overloading. So if they have a really complicated lesson, so if they don't have a lot of prior knowledge and they're presented with a complicated idea, the material just might be overloading for them. So how do we cope with that? We can't remove material because it's all essential, it's all important, but that important information is too much to be grasped. 3 techniques that I want to look at are segmenting, pre-training, and modality. So let me look at those. So these are techniques for managing essential processing. So for segmenting, the idea is, let's take a long, complicated lesson and break it into smaller parts, and make sure you can kind of intellectually digest one part before you move on to the next part. So if we go back to this lesson on the lightning, on how lightning storms develop, we broke it into 16 segments. Each one is about 1 sentence long, runs for about 10 seconds maybe. So here's how it starts. Cool, moist air moves over a warmer surface and becomes heated. So you kind of see the animation, you hear the voice, then it stops, and you have to click on the continue key to go on to the next segment. That's a very simple way to let learners kind of manage the pacing of a lesson, versus just having a continuous presentation where they just watch the whole thing for 2.5 minutes without any stops in it. Another way to do this is from a lesson on geographic information systems that's used in introductory college courses in geography. I won't go, it's kind of hard to even see what this is about, but we could present this as a progression, as a slide that progressively gets filled in. So sometimes when people are giving PowerPoint presentations, each slide gets filled in, or we could just present kind of the final slide, the one in the bottom right corner, all at once, and have people deal with that. So the segmented version is to present it piece by piece. In 7 out of 7 experiments we did, people did better on a transfer test when there were learner-paced segments rather than a continuous presentation. And there was a median effect size of 0.67. So this is pretty good evidence for sometimes segmenting lessons, where we as the instructor choose where to break it at conceptual places and then let the learner kind of move on. So these are some of the studies that looked at that. The pre-training principle is a kind of similar idea, but here the idea is, before we present the actual multimedia lesson, let's make sure learners know all the key terms. So the idea here is that people learn better when they receive pre-training in the names and characteristics of the key concepts or key parts before they get the actual lesson. So here for a lesson on how cars braking systems work, before they actually see the narrated animation, they get to kind of click on each part, like the master cylinder. If they click on that, then they get a little highlighted area that shows them where it is and shows what it does. So for each part, they can click on it and see where it is and what it does. So that's pre-training. Other learners don't get that pre-training. They just go straight to the actual multimedia lesson. What we find is in 10 out of 10 experiments we did using different kinds of topics, people learn more deeply from a narrated animation when they have pre-training in the names and characteristics of the key concepts or components, with a median effect size of 0.78. Again, a large effect. So segmenting and pre-training are two pretty effective ways of helping learners cope with a complicated lesson that they have to deal with. And it's complicated for them. I mean, when I say complicated, it means the same lesson could be complicated for one person and not complicated for somebody else. So we have to also consider the individual learner's prior knowledge and skills. So these are some of the studies that looked at the pre-training principle. Finally, one other way of helping people manage their essential processing is to switch from presenting words as narration, from on-screen text, to presenting them as narration. So if we look at, say, I'm just using this example of the lightning passage since we're kind of familiar with it by now. We can present it with on-screen text on the right. So you're watching the animation and you're getting these captions at the bottom. So there's 16 different captions like this. Or we can, the problem with that is it creates split attention, as we've talked about before. If you're looking at the words, you can't be looking at the animation and vice versa. We can offload the words onto the auditory channel, because on the right here, everything's going through the visual channel. When we use words as narration, we can offload some of the visual demand onto the auditory channel. So the words are now coming in through your ears, the narration is coming in through your eyes. We've effectively increased your processing capacity, and this helps people learn better. In 18 out of 19 experiments that we've done, people learn better when the words are spoken rather than printed. So we call that the Modality Principle. This is one of the most studied multimedia principles. There's lots of boundary conditions that I've kind of already mentioned. Things like when the words are unfamiliar, it's good for them to be printed. When you're not learning in your first language, it's good for them to be printed. And sometimes even just having short little phrases can help. And here are the studies that support that Modality Principle. Okay, so how can we help manage essential processing? We can use segmenting, where we present, let's say, an animation in learner-paced segments. We're going to have pre-training, where students are taught the names and characteristics of the key components, and modality, where we kind of complement the graphics we're presenting with spoken explanations. Lastly, so let's say we've eliminated extraneous processing. We have helped manage essential processing. And people still might have some cognitive capacity left, but they don't use it to try and make sense out of the material. They kind of get it into their working memory, but then they don't really try to reflect on it or relate it to their prior knowledge or think about what it means. How can we get people to process the material more deeply, try and make sense out of it? I want to look at 3 principles that we've investigated and I'm pretty confident of based on our research. So these are all attempts to foster generative processing. personalization, voice, and embodiment. By personalization, I just mean putting the words into conversational language. Typically, textbooks and instructors even use what I would call non-personalized language. They use third-person construction. So this is from a lesson on the human respiratory system, how the human lungs work. We took this from a textbook. During inhaling, the diaphragm moves down, creating more space for the lungs. Air enters through the nose or mouth, moves down through the throat and bronchial tubes to tiny air sacs in the lungs. That's all third-person formal language. We can personalize it by simply changing the to your. So when we use I, you, we, your, us, so we're using first and second person, that's more personal. So that's why I'm calling this personalized. So during inhaling, your diaphragm moves down, creating more space for your lungs. I wouldn't emphasize the your, but I'm just doing it for this. So in one study, we just changed the to your in 19 different places in the lesson. That had a huge effect on learning. That's kind of what got us started with the personalization principle. And then we looked at it in lots of other contexts. So in 14 out of 17 experiments that we've conducted, people learn more deeply when the words are in conversational style rather than formal style, with a median effect size of 0.79. So just trying for me to say, hey, hi, you all. that's supposed to maybe create better generative processing, presumably because you develop more of a relationship with the instructor and want to kind of work harder to understand what the instructor's telling you. So these are some of the studies we looked at, both for lightning, for a botany game, for how the respiratory system works, which was the example I showed you, and so on. One other way of trying to promote deeper processing is to look at voice. Voice is carries a lot of social cues, a lot of social information, and people can develop a kind of feeling towards the instructor just based on their voice, whether they like the instructor, whether they think the instructor is trying to help them. People develop a relationship with the instructor just through their voice. That's the idea here. And so in some of our studies, we compared a friendly, positive human voice to a kind of monotone machine voice. So some of these studies were done before some of the advancements in machine voices. In 5 out of 6 studies, we find that people learn more deeply when narration is spoken in a friendly, positive human voice than a machine voice, with a median effect size of 0.74. And these are some of the studies that looked at that. Lastly, let me look at the embodiment principle. Oh, I'm doing okay for time. The embodiment principle is the idea that students learn better when the on-screen instructor gestures while explaining the slides. So it can either be an animated on-screen agent, or it can be, let's say, an instructional video that shows an actual human instructor. The idea is if that instructor uses human gesture, so you use your hands, you use facial expression, you use eye contact, even body stance, those features promote learning. So this comes from a lesson on how solar cells work, which is pretty complicated and gets down to the level of atomic structure. So in one version of this, we have an on-screen agent who's explaining it to you. His lips move, but he stands completely still as he's explaining it, and these little slides appear next to him. And we have another version where he actually gestures, uses human-like gesture, facial expression, eye contact. So that's the embodied version. Another way of looking at this is if we look at an instructional video. Here we have Celeste, who is a student a few years ago in our lab. Here she is explaining, probably can't really tell from this, but she's explaining the Doppler effect. And she's either just talking about a material that's already there, so drawings that are already there, or she's drawing it as she lectures. So the one on the right is more like a talk and chalk approach. And the one on the left is more like a traditional PowerPoint presentation, although that's not a PowerPoint slide, but it's already drawn. Here we find that students learn better when she draws it as she's lecturing rather than if it's already drawn. It's as if this element of embodiment where she's drawing it, it's almost as if you feel like you're drawing it with her. That's kind of the idea here. And we get the same thing if we have a video with just the hand drawing it as the lecture's going on versus having a voice that's just describing a graphic that's already drawn. People learn better from the version on the right where the instructor draws as she's explaining than the one on the left. And this is kind of the same idea. One other version of embodiment is the angle at which we film a video. The one on the left here is showing how to construct a circuit, an electrical circuit, from a first-person perspective. So the voice is explaining what he's doing, and he's putting the circuits on the circuit board, but it's filmed with the camera over his shoulder. So it's from his perspective. And the idea is it feels kind of like those might be your hands, although maybe they're not that hairy or whatever, but they're your hands doing this. Or we could film it from a third-person perspective, which is typically what you would see on YouTube. You know, your buddy is there filming you doing something. So we kind of filmed exactly the same thing that was going on with a camera, one camera on his shoulder, another camera across the room from him, across the table from him, and the exact same voice. People learn better from a first-person perspective than a third-person perspective. Again, I think there's this element of embodiment here where you're kind of feeling like maybe that's your hands doing this. So I would kind of summarize this principle like this. People learn more deeply from multimedia presentations when the on-screen instructor uses appropriate gesture, facial expression, body stance, and eye gaze. In 16 out of 17 studies, we get that effect with a median effect size of 0.58. But it also involves some of these other things as well. So let me kind of break this down for you. Some of the research involves gesture, as we were talking about. You can see in studies where we're looking at gesture, adding instructors who gesture rather than just stand still greatly helps. The next set is instructors who draw as they're talking rather than just having the drawing already on the screen or on the board. That helps. Instructor maintaining eye contact while lecturing, that helps. Or the instructor being shown from a first-person perspective rather than third, that helps. So if we look at these techniques for fostering generative processing, we see that the personalization principle, people learn better when words are in conversational style rather than formal style. The voice principle, which is that people learn better from a positive, friendly human voice than a kind of sounding uncaring machine voice, and the embodiment principle. So this is kind of the summary. So these are 11 principles. So along with the multimedia principle that we already looked at, I've tried to share with you very briefly our research that supports these 12 principles of multimedia design. I won't repeat them all here. So let me just kind of summarize and get to the bottom line here. I think the idea here is that people learn better when multimedia messages are designed based on what we know about how people learn. So they're based on theory, when they're based on evidence, so actual studies that have investigated it, and when they focus on learning outcomes like performance on transfer tests. If you're interested in more information, I'm sorry to suggest my books, but I want you to have the best. No, I'm only kidding. But these are some sources that you might want to look at. So I'm now really happy to answer any questions you have. I really appreciate your patience and attention.
Thank you, Rich. We have a couple questions, actually 12. And if it's okay, I'll just start at the top and read them to you, if that's okay, or I could send in the chat to you. Which one do you prefer?
Oh, no, please. I need to hear them. That's good.
Okay. The first one is from John Robinson. He says, how do you think life and work for the next generation of educational psychology researchers will differ from your own experience? Less about particular areas of inquiry, more about career advice.
Huh. That's a really good question. When I just kind of think about what advice I would have given myself 40 years ago, some of the things I didn't realize that I realize now are things like this. I didn't realize how much of a social activity research is. I mean, my conception of research was, oh, I'll get a lab and I'll work in my lab and collect data and publish papers. That'll be good. But that's not how it works at all. Our research, I mean, the research that we do is so multidisciplinary. When you're involved in educational psychology or educational technology, there's lots of different disciplines involved there. The people who know about technology, the people who know about learning theory, the people who know about the content. So all the research I do is always with teams of other people. So that's one thing I do not think will change. I think it will probably continue to get even more multidisciplinary and more social. Let's see, when I think of other things like that, I also didn't realize how much criticism we get. So we get a lot of, we live also in a social world. You have to convince your colleagues that you have good ideas. You have to get feedback from your colleagues, and a lot of the times the way you get feedback is your paper keeps getting rejected. So I think you have to develop confidence in yourself. If you think you really have a good idea, persist with it. And if the reviewers really are right, you have to admit, yeah, they have a good point there. So I think you have to learn how to take criticism and use it to your benefit to move ahead. Trying to think what other advice would I give myself. I don't think that's going to change either. I don't know if things are going to change a lot. And I guess kind of along those same lines. Sometimes people, say nice things about you. You get awards, but I think the same way you deal with criticism, I would deal with that. I mean, that's nice that people say nice things. I really appreciate it, but I think you really start to get in trouble if you keep reading over all the nice things people write or all the awards you get. That's not the point. The point, I think, is to pursue the research questions that are important to you and to try and get the answers to those questions. So kind of, I think what guides me and what will guide people in the future is a curiosity about questions we want to have answered. So I think the most important thing really is to have good curiosity. And I don't think that's going to change either.
Thank you. A second question is about concept maps. How can we as educators apply the multimedia principles to instruction using concept maps to reduce cognitive load and foster the transfer of learning?
Yeah, I mean, I think there's two sides to concept maps. So they can be used as an adjunct. So we can present, like, let's say the lesson and then a map in the margin or something like that. So that's, I think that's kind of more like the multimedia principle, because you might have text and then the map is kind of like a graphic that spatially represents the text. I think research shows that if you do that sparingly, it helps learning. We've done some studies along those lines that show if you present concept maps along with text, not too many, but just maybe one per paragraph or something, that helps learning. Another way to use concept maps is to try to have the learner actually generate the map, so to use it as a learning strategy rather than as a instructional design feature. So if we use it as a learning strategy, I think students need practice and training in how to actually generate maps. And they also probably need a little scaffolding, because just creating them takes a lot of effort. So they might need maybe just a partially filled out map that they fill in, or some system that allows them to do it easily. But I think that's another area that could help people learn, what I would call a mapping strategy.
Thank you. Some of these questions are anonymous, so this one is from an anonymous individual. Should multimedia principles also apply to virtual PowerPoint presentations? For instance, I feel like the cognitive load extraneous processing is high during virtual presentations when you have to listen to what the presenter says and what they're saying doesn't match the text visually or what is on screen. Is there science to address this?
Yeah, for sure. It definitely applies. I think, our original research with multimedia learning was kind of paper-based, because we started really in the 80s. But it also applies to computer-based and e-learning situations. I think it applies to the design of instructional games. It applies to the design of immersive virtual reality experiences. So I think it applies to all those situations. And yeah, when you're talking about like a virtual presentation, even an instructional video, yeah, I think there's lots of room for improvement. There's lots of ways to apply these principles to improve instructional. I'd really like to spend more time just focusing just on instructional video, for example, since we're kind of all living in this world where we watch a lot of instructional videos, either live or asynchronous. I think we can do a much better job of designing them. So based on these principles. So we've done an increasing amount of work with instructional video, trying to focus on that. And I think we have kind of shown that these same principles apply to that situation the questioner is asking about.
Thank you. This next question says, we need to provide closed captions for all of our videos. Does this lead to split attention? I've heard from UDL experts that captions actually help retention.
Yeah, I think that could help retention, because you kind of remember the words when they're printed. But, retention is one thing we're going for, but transfer is also something we want. And they're not necessarily the same thing. I mean, you do have to remember the material so that you can use it and transfer from it, but you don't want to kind of remember it in a really rote way. So I think we really have to consider when captions might be helpful and when they're not helpful. I think if so this is our problem. We have a limited working memory. If we have to process those printed captions and we have to view what's ever on the screen, if what's on the screen is fast moving or if it's complicated, it might overload our visual system. So we don't want a situation where the captions are going to add so much demand on the visual system that it overloads. So if the lesson is slow paced, or if the learners are knowledgeable and they can manage that much visual information, that's fine. But if it's fast paced and it's the learners aren't that experienced, we have a chance of overloading the visual system. In that case, captions could be a problem. I think the positive part of captions is, well, they're definitely helpful when you're learning in a second language. We have research that shows that. And a lot of students, especially college students, they're taking courses in English when English is not their first language. So we need to figure out ways to support them in that. And captions is certainly one way to do that. Also, if there's a lot of technical jargon, names of chemicals or things, it's probably good for those to be printed. And even kind of the key ideas, maybe just a phrase, if that's printed, that might be helpful. It's just when there's a whole lot of text and the lesson's going by at a fast pace, that could be problematic. So I think we just have to consider the situation, the learner, and really just the load on working memory. If we're not overloading visual memory or the visual channel, then yeah, captions are fine. But in general, if you don't need it because the lesson's in your first language and you know the words are familiar to you, you probably don't need the captions. They probably are going to create extraneous load.
Thank you. This question is, do you think the effects of these multimedia instructional principles could be different depending on students' cultural backgrounds?
I would say, can you elaborate on that? But I guess you can't because that wasn't your question. Well, I think that's a huge area of importance, kind of cultural background of the learners, because most of the research we have in our journals are, they're college students from research universities. So that really not representative of the world that much, although there are a lot of international students now at our universities, but they're probably not representative of their culture either. So I think that's a really important question. I think so. I mean, I think these would apply everywhere because, even the very earliest version of multimedia instruction was a book by Comenius, who was a Polish cleric, really, who he developed the first children's picture book, really, in the 1500s, and it kind of showed scenes. So it had pictures, and then it had like it might have a scene of let's say a barnyard, and it would like have a number on each thing in it, and then it would have a legend that would tell you lamb, cow, pig, I guess, and both in Latin and in your language. And then maybe a description of what these things are. So we know that was hugely successful in Europe for 100 years. So we know at least across those European culture, it was useful. But I think we know enough from our research and that it's been conducted in lots of different countries and come up with similar results that I'm pretty confident that it applies across boundaries.
Thank you. This question is black text on white background preferred to enhance multimedia learning?
That's a really good question too. It's more of like the perceptual quality of the material. I have buddies in perception who, they always want to have white on black. I don't know. They're just weird in general, maybe. I don't know. But I think we're used to black on white. That's kind of, that's how books are printed. That's kind of what we expect to see on a screen. So I think just because it's more familiar, it's probably a preferred way to do it, but that's really a researchable question. So I think that would be a fun question. Some people have looked at it, fonts, like are certain fonts better than others? And there's a huge literature on that. And some people have argued that having a really hard to read font is actually good because you have to try harder to read it. But there's really not evidence supporting that kind of idea.
This next question is, when thinking about your own work on multimedia learning, does perceptual learning and expertise play a role?
Perceptual learning. So just kind of your ability to see the graphics, maybe your spatial ability. Is that, I think, what?
That was my question, to be honest. It was from some of the work by UCLA, he's at UCLA, Kelman, where he has perceptual learning in medicine. And I was curious how perceptual learning would affect multimedia presentations with differing levels of expertise.
So kind of training people to be better at perceiving things.
Yeah.
Yeah, I think that's really an understudied issue. We put a lot of effort into teaching reading comprehension, like how do you process words? Want people to be able to understand printed material, but we don't put a lot of effort into how to process graphics. And I think, yeah, that's it kind of maybe comes under the heading of media literacy or new literacy, sometimes people call it. But I think that's hugely important. I don't think people are particularly good at processing graphics. They don't know where to look or what they're supposed to get out of it. And a lot of people, I think, still view the graphics as irrelevant. It's really just the words that are important. So I think if that's what we mean by perceptual learning, I do think people need to learn how to process graphics. So we need like graphics comprehension and reading comprehension.
Thank you. Have you or your colleagues experimented with these principles when one or more modalities may be impaired? So for example, hearing impaired or visually impaired.
Yeah, I get that question a lot from my students in my class. I personally haven't done that, but I would really like to. I think that's an important issue. I know there's been some little bit of research along these lines I'm aware of, but it's kind of I think it's still pretty much an open area for me. I don't know a lot about that. Also, people ask like, well, what about other modalities besides just words and pictures? What about touch and smell and other senses we have? So that's a whole nother world to go into. But I've been so overwhelmed by just words and pictures with learners who are have are able to process those that I haven't progressed out of that yet.
Thank you. This question is, I'm interested in why the chemistry results varied. Is personalization domain dependent?
I don't think we can really draw that conclusion, but I also was kind of concerned about it. But I think it was because of the kind of lesson we had. That was more of a tutoring. It was kind of a cognitive tutoring system. So I think it maybe had more to do with the fact that we were working with an intelligent tutoring system rather than just a flat out presentation. And the tutoring system was interacting with you, in let's say a personalized way or a non-personalized way. So I don't think it was because it was chemistry. I think it was because of the fact that we were using an intelligent tutoring system rather than just a presentation.
Okay. This question is, how many teachers or institutions have learned the information you provided this afternoon?
Yeah, that is a really great question. And my students in my class asked me that too. Like, yeah, does anybody actually ever use this? I think that, that's an issue for all of us who do this kind of research. Like, how do we communicate our results? So, I mean, one attempt is to try and write for practitioners. So I have a book that I wrote with Ruth Clark, who is a kind of a consultant to the instructional design departments of corporations and companies in the military, the people who are actually designing instruction. I have a book called E-Learning and the Science of Instruction, where we try to write it more for practitioners, still take an evidence-based approach, but write it, for practitioners, not to impress our fellow researchers. That's one way. I've gotten more interest, I would say, from The business world, military, professional schools like medical schools, they seem to be more interested in our principles than, let's say, K-12 education, because I think K-12 education is very resistant to change. It's hard to move it. So I think it will maybe happen as the teachers who are being educated, hopefully take courses in learning or learning science, or somehow it filters into the courses they take in college. I think maybe then they'll be more receptive. But I find it interesting that for me, the impact seems to have been being stronger in adult education.
Okay. So this isn't worded as a question, but I think there's a question in here. I'm strongly interested in applying visualization technologies to instruction in real classrooms and wondering how to solve the problem of lacking fidelity in research in the multimedia learning design, since many of the studies conducted in a lab setting or visited in a classroom for a short term. The authentic classroom can be a very different story, and the effectiveness of such visualizations and technology could be decreased.
That's for sure. That's always the challenge, to try to take these lab studies. I mean, most of our studies are like short-term lab studies. Maybe they last less than an hour, and yeah, they get nice effects, and then we move on. But when you look at a classroom study with all the complexity of a classroom, or you try to look at a more long-term study, that I think that takes a lot of courage to do that kind of research, or to try to do that kind of application. But the few studies I'm aware of that have taken these principles and applied them in classrooms have been successful. It might be people who have unsuccessful adventures don't tell me about it, or don't get it published or something. But I think there are enough studies that have been done in actual classrooms that I have some confidence that you can apply these principles. Kind of at the end of these slides, I had like a study that was done in medical school where they took lectures. I mean, in your first 2 years of medical school, you get a lot of just book learning and listening to PowerPoint presentations, apparently. So they took some of the lessons, the original version, and they converted them based on Mayer's principles of instructional design. And they compared those with, in medical schools, you have new classes coming in like every 6 weeks, so they could compare across those classes. And they found that the, enhanced design version of the lecture resulted in better test performance than the regular version. We don't know if the doctors turned out to be better doctors, but they did do better on their tests and also on delayed tests. So that was a real world environment. It made me feel like, okay, that's good. And at least it worked there. So, but I do think we need to think a lot more about what it means to apply these in real classrooms. But I do think a lot of teachers are already doing things like this. When I visit classrooms, I see them doing this. So I think they've maybe hit upon some of these ideas just based on their experience.
Okay. This question is, have you studied icons? Are they similar to images, or are they more like signaling?
So icons like you mean like I think they're more like images, but I haven't studied them per se, but I know that there's a whole big field, obviously, of how to design icons, how to communicate through icons. So I think that's a fun research area. I haven't gotten involved in it, but I do think, yeah, those are visualizations.
Okay. Can you speak about how we can apply these principles to decide on which or when to use which types of media, such as video or text and graphics, when developing an online self-paced lesson?
Mm-hmm. Yeah, that's a really good question too. I haven't really looked at, which media are best for which kinds of situations. I know that's something in the world of instructional design we're all really focused on. But my issue has been more, if we're going to use instructional video, what would be the best way to design it? Or if we're going to use animations, what would be the best way to design those? Or if we're going to have on-screen pedagogical agents, how should they behave? So I've kind of like focused more on, given that we're going to use this format, what would be the best way to design it? Or given that we're going to have games, what would be the best way to design an effective game? I think sometimes, media comparison research, where you kind of ask which medium is better, it's really hard to do that kind of research, and it's hard to interpret the results of that kind of research because it's never really completely possible to separate the instructional method from the instructional medium. So, because certain media allow for different instructional methods. So those kind of media questions that, people ask, like, is it better? Do people learn better from games or from conventional media? It's hard to answer because they're so different. The methods that are involved are different. So I've kind of stuck more to the more instructional design question, like, if you're using this medium, what's the best design? I think they all have their place. I mean, I do think, instructional videos are going to be around for a long time, so it'd be good to know how those work. I think animations are going to be around. I think virtual reality we're going to have more and more virtual reality type lessons, so we need to see when are those going to be effective? I think that's a really valid question to ask, which kinds of learning objectives kind of match with which kind of media. I just don't have a great answer right now.
Thank you. Well, we only have 2 minutes. Maybe we could do one more question. And this person asked, you touched on pre-training and segmenting. As online education appears to be a likely part of higher education, do you think educators should better train students for online learning in primary and secondary schools?
For sure. And I actually think that is going on. And when I see, maybe I see what my grandkids are doing, they're being asked to create multimedia presentations in elementary school. They make these fantastic PowerPoint presentations. They're really good at it. So I do think, the whole concept of literacy is changing. Literacy is not just reading books and writing essays. It's being able to create multimedia communications and being able to comprehend them. So being able to communicate with other people and to understand other people's multimedia communications, I think, that should start in kindergarten.
Thank you. Well, we're out of time. I just want to thank you from School of Education for spending an hour and a half with us talking about principles of multimedia learning and giving us some really good information to think about as we design face-to-face and online and hybrid classes.
Well, thank you. I've really enjoyed it. I appreciated your questions, and it's been a lovely visit. I hope someday I'll get to come there physically.
Thank you.